Okay, take out your assignment from yesterday. Let's pull that up. I hope you noticed a few things. Did you notice how close did you notice the problems are exactly what we did in notes in a lot of cases? And I had people going, Bloom, what did you do here? I go, you didn't watch the video. Oh, I watched it. Oh, no, you didn't. Not possible. Not on this side, because that's the same problem you're asking a question on. I did in the notes on the video. Really? No, dude, do what you're supposed to do. Please, 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 please. So I ain't wasting time with these. We're done with them. And a matter of fact, yeah, this is the only one I didn't do. And check it out. Once I draw that picture, do you got area? 120, right? It's 24 times 10 divided by 2. So now we're going on to that next one. We're looking on this side, and I know I got some numbers here. The red was 16, the yellow was 32. The white is 14 times 4, the square root of 3 minus 32. Now, I got some people that got it, and they're like, how in the world did you do that, Bloom? Keep in mind, this triangle, they tell me this is 4 secretly. This whole length is 14. This is 10 of it. That's how I know that's 4. What's half of 8? Check it out. Do you remember 30, 60, 90 triangles? Well, you should, because we're coming back today. That's how I know that that's for the square root of 3, because of a 30, 60, 90. It's not just because we covered it, but we covered it and I guaranteed it would be back in the last few chapters. Second semester is awesome in order to prepare for the final, because we review all the hard stuff the entire semester. If you're one of those that just blow it off and goes, oh, how much of this can be on the test? Dude, start learning them, okay? There are 18 questions just from chapter 8 on the final, okay? The remaining chapters have 7 or 8 questions from them. There are 18 from chapter 8, and I think I have another chapter, I think it's 7, that I favor like 12. And yeah, I wrote the final, with a couple other instructors a couple of years ago, and we still use it, okay? Make sure you're ready for it, because it's there, okay? Sounds like you're threatening. No, I'm just promising, man. You got to help me out. I'm just telling you what I'm going to do. Okay, so now here's the dealio. In this next one, in 20, this wasn't. 22 was, 20 and 21 were not. So here's the deal. I want to bring this up to you. Check this out. Do you see that? It's almost like I traced it in there and then pulled it out, right? That triangle has dimensions of 14 base, 14 height. Do you see where the 14 by 14 comes from? I'm taking that triangle away from the other one that's sitting there, right? I mean, the square, really. This triangle's taken away. Ooh, boy, that's really cool. This triangle's being taken away from the square. So really what I've got is 14 squared minus 1/2 of 14 squared. If I take 14 squared, which is 196, and I take away half of 14 squared, which is 98, how much is left? 98. Done. 20 is 98 square units, or in this case, feet squared, because I'm just taking away half of it. This type of triangle question, the square minus triangle, there's yet to be an MCA, ACT, SAT combo that I haven't seen it on one of those 3 or all 3. Okay, make sure you're friendly with it. In 21, when we're doing this, now I have not formally gone over this equation that I used. This is a trapezoid equation. It's 1/2 height times the sum of the 2 bases. Yet you did it in 5th grade, 6th grade, 7th grade, and 8th grade. Yeah, I know. People, what? No, this is recursive information. Matter of fact, I'm not sure if you've recognized everything that I've gone over this year is kind of recursive, except for side, 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 side angle, side angle, side angle. We've done ratios before. We've done similar figures before. Okay, we've done corresponding sides before stuff. We've done XY coordinate grids, so we've done linear stuff before. I just review it all. We've done perpendicular and parallel linear stuff. We've done point slope form, slope intercept form. We've done vertical and horizontal lines. We've done distance formula, we've done Pythagorean theorem, we've done supplementary, complementary, adding stuff up to 180 for interior angles of a triangle. All the stuff is all review. All of it. It's recursive review. It just comes to a head here in geometry. Okay? We just need to make sure we reread and re-know. That's all. Any other questions on the, oh, I got to do this one. This is 10, remember, parallelogram, opposite sides of the same measure. That's 10 too. That makes this 24, 10 plus 14. That's where the 10 plus 24 times 10 comes from. Remember, the area of a trapezoid is just the average of the two bases times the height. That makes it kind of parallelogram-ish, okay, as we go through. You will have a quiz today on this assignment. No notes. I will leave a screen of notes up there, but it's not necessary. Yes, miss. Oh, plus base, base, base and base. It's the two base. Hell yeah, yeah, you do, because that is a trapezoid. Parallelogram, the base is consistent. Remember, in a parallelogram, when we do it, and this is an example of it, this is a parallelogram, opposite sides of the same measure. And a trapezoid doesn't have to have that. They just have to be parallel. Any other follow-up questions? Okay, a little hippity hoppity. Put your name on that if you're all done. If you are not, you need to finish. Okay, and I guarantee having done it will be helpful. Okay, today's notes. We're off and running. Hey, what a great segue. Bloom just ended corrections with a trapezoid. Woohoo! This is today's objective on 10-2, day 1 and day 2, because we're doing both days. That I've always split it apart, but we're getting after it, and I'm skipping some stuff because we're going to favor it for our block schedule day on Monday or Tuesday next week, because we got that MCA testing, so we're doing blocks, so we'll be able to get that done. What I want you to know, focus, focus, focus. What I want you to know, this is what we've got. I gave you the formula. I gave you that this is the base, that's the base. I don't care how you add them because addition is commutative. Get after it. Go. I'm going to even give you that hint as we get going. Okay, you guys are all done here? Okay. Life goes pretty quick. If you don't pay attention to what's happening, you're going to be left on the wayside of the road. Half times my height, which is 10, 9 plus 6. 9 plus 6 is 25. Half of 25 is 12.5 times 10 is 125. So we should be done. Right now, if you got questions, ask them because that's it. That's what you're doing on the next two. Are there any? And you shouldn't be copying from mine from here on out because you're using a formula. Just make sure that you write the formula down each time, just like I did, because when you reread your notes, it should be a reread, not a refigure. I always got people going, I got an answer, 125. Oh, great. How did you do it? I don't know. I'll figure it out. I'll read them. Oh, this is what I did. When you reread your notes, reviewing for quizzes and tests, or just looking for stuff in the quiz, it should be written out. So you go, oh, that's what I need. It should be that fast. It's a reference material. It is not sneaky and hidden. If it is sneaky and hidden, start doing your notes much better. Okay, do 2 and 3 quickly. Quickly. Rock through 2 and 3. Remember, let your calculator do the walking. It's a snap. Look left, look right, talk to people around you. They probably have the same answer. Move on. If they don't, ooh, got to have a discussion. Is it working? How's the heart working today? Nobody scared you at the door? Oh, I told my imaginary friend to do it and didn't take care of that. That's right. He's imaginary to you. That's sorry. Yeah, it's a me thing. All right, so here we go. We got number 2. And I've got my 2 bases, 22 plus 9, and my height's 7.5. So I'm just getting after it. Now I'm done. Okay, 116.25 meters squared. Remember, dress up your numbers. They don't want to go outside naked. Okay, make sure they have units on them. Okay, you can look at it as a onesie. Okay, the little units. This next one, the difficulty level was ramped up because I twisted the shape 90 degrees. Okay, the 2 bases are 13 and 4, so I put those in there, multiply by 7, divide by 2, and I'm working with my calculator, 59.5 yards squared. Are there questions regarding these 3? We have 3 more quite quickly will happen to us. And remember, this is a formula chapter. Yeah. Monday. It'll be rock starry. Other questions? Okay. Moving on. We have the area of a rhombus or a kite, and the area of a rhombus or a kite is half the product of the length of the diagonals. Now this might be new. You might have broken up these triangles or these shapes as triangles before, okay, to find their areas using 1/2 base times height, using the diagonal as the base and then the partial of another diagonal as the height. Because of that, this area formula with the product of the 2 diagonals divided by 2, that has evolved to that. Okay, it's kind of a neat deal. Any 4-sided figure that has perpendicular diagonals, if you know the length of the 2 diagonals, you can find the area. Okay, even if it's not, it can't be categorized as a kite or rhombus. Okay, now, you ready? The hardest part of this isn't the fact that, oh, that's a diagonal and that's a diagonal. It's what is 2 plus 6.5? It is 8.5. And what is 4 plus 4? It is 8. Those are the 2 hardest things because people have a tendency to multiply for some reason, and I've seen it happen hundreds of times, so make sure you're careful. But once you add those 2 different pieces of the diagonal together, you multiply, divide by 2, and you're golden, 34 feet squared. Go ahead, do 5. And pay attention to 6, how I define them. The first half of the diagonal is 25, and the first half of the diagonal is 22, because rhombuses have some properties that we're reviewing. First of all, the diagonals meet at right angles. Secondly, the diagonals are mutual bisectors of each other. Thirdly, the diagonals are interior angle bisectors. Where they come together, they're angle bisectors of the sides they come to. In parallelogram, opposite angles are the same measure. So opposite halves are the same measure too. Go ahead, do 4, 5, and 6, and then start rejoicing over Pythagorean theorem for this last one here. Zits, that's kind of an interesting thing. Let's see if we can get rid of it completely. Cut, thank you. All right. Doing a great job, keep it up. Keep it up, doing a great job. Remember, your calculator on your cell phone does not do true view screen functions. So it makes it tougher to use. Make sure you always have a calculator that you will use on a quiz or test in your possession on a daily basis so you're more successful in knowing how to use them. Eight times 6 is 48, divided by 2 is 24. Doing okay? That one was quick. 25 doubled, 50. 22 doubled, 44. 22 times 50, 1100. We doing okay there? People are feeling, yes, that's what I've got. Okay, you don't want fat fingeritis to take over and go crazy, but really what I'm doing is just arithmetic with formulas, order of operations, once I know what I'm plugging in. And the stuff I know I'm plugging in is review from chapter 6, rhombuses, okay? Now, the next thing I'm gonna do is when I had an unknown side and I have a right triangle. Keep in mind, I have a right triangle. This is a rhombus. This is a right triangle because the diagonals of rhombus meet a right angle. The diagonals of rhombus are mutual bisectors of each other. So I was told that this is 4, and so therefore, oops, that's 4 as well, that little spot. Maybe I'll make that a different color so you guys can make blue a different color with blue. Stop laughing at me, Minahan. Okay, see, I'm going to tell my brother on you. Okay, here's the deal. As we're going over here, we've got 4, right? How do I find that missing side in a right triangle? It's Pythagorean theorem. That'll be so cool, right? I got to pull that out. I got to find the missing diagonal, so I got to pull out Pythagorean theorem. I've got the hypotenuse, which is 6. I got one of the sides. I don't care which one you put it in, A or B, one of the sides, but you got to find the other one. So I got 36 and 16, and I subtract them, and I get 20. I take the square root of 20, and I've got A is the square root of 20. If I was going to use it for a calculation, the square root of 20 is perfectly fine. Okay, but I also want to take this opportunity to teach you guys, or not teach, remind us about that simplification of square roots. You know, I got a perfect square in 20, it's 4. The square root of 4 is 2, so 4 times 5, so it's 2 to the square root of 5 as I go through. So if it was going to be a pretty answer, that's it. Now, that's a lot of work for just a factor I'm going to use. But we got to do it. And I'm going to use red. This is 2 the square root of 5, and so is this, because they're identical. 2 the square root of 5 plus 2 the square root of 5 is the same as 2 times 2 the square root of 5, which is just 4 the square root of 5. Okay? And people are like, well, why are you doing that? Well, because I'm looking for area. I got to remember why I'm here. And I pop that in, and I got half of 8, which is 4. And I got 4 times 4, which is 16 the square root of 5. If I have in directions, hey, I want you to put this in simplest radical form. I want 16 the square root of 5. If I have on the directions, hey, I want it to the nearest 10th, 100th, 1000th, or even if I don't, always go to the 100th, you got that, 35.78 meters squared. Let your finger do the walking. It's a snap on that calculator, right? Unless you got a cell phone. They're tougher with that square. They're tougher to use. I'm going to be honest. They're tough. Those cell phones, they've got to come up with true view equation stuff. That'll be cool. Cool. Now, we are done with page 1 of chapter 10, section 2 notes. How you doing? Are there any questions? Okay, turn the page. Go to problem 11. We're going to skip 8, 9, 10. I guess 12, I lied, not 11, 12. Go to problem 12 next. Okay, we're on problem 12. We're sitting at getting these notes done and completed. Okay, so we're on page 2 of 10.2, and we're at problem 12. One diagonal of a rhombus is 5 less than twice the other. Dude, I totally skipped these in algebra. I totally asked these the next day. That was what I did. Okay, that's what I get from students. Here's what I want you to do. Let's use money. If I have $10, and if you have 5 less than twice as much, so what's twice as much as 10? Everybody's going, it's 20. It's 20, Bloom. That's 20 bucks. Now take 5 away. That's 15. I have $15. Are you following along with what I did? Same problem. When we do these problems as teachers, when we have them in books, we are assuming you know the secret, and here it is. And we went through the secret first semester and second semester, first part. One of them has to be X. We're comparing it. We're using a variable. It doesn't have to be X, it could be Y, it could be Z, but it's consistent unknown variable. And then we compare it to the other. You guys compare stuff all the way. Your phone's better than mine. Your shirt's cooler than mine. I got a better score on that test than you. Comparison happens all the time. Know that when we do it in a algebra sentence word problem like this, one of them have to be plain old everyday X. They don't tell you, well, one of them's X and the other one's 5 less than twice it. because that'd be, well, that's 2x minus 5. They don't make that assumption. I mean, I don't write them out that way. We have you make the assumption that one of them's got to be x. And to do these, if you just assume one of them's the unknown, you just do it. So now that we know that, one is x, the other one's 2x minus 5. 75, where do I get that? Because I'm told up in the problem that the area is 75. At this point, I'm going to multiply by 2 on both sides. That gives me that. Okay, are you starting to see the quadratic formula turn its face and smile at us? Pretty cool, right? But if you're really good at FOIL, unfoil, it's even better. Okay, so here's the deal. I've got to get everything on the same side. Okay. Stanky's pumped up. He likes FOIL, unfoil. He's all excited. Stopped in this morning and go, Bloom, can I FOIL, unfoil today? I go, yeah, no problem, thanks. We will take care of you, buddy. Okay, so here it is. Now, when I do these, okay, since 2's prime, I got 2x and x. I separate those, okay? But then I'm just going to go, I'm going after that 150. Fastest, quickest two factors you see in 150. Do you see 15 and 10? And people are like, well, I see 3 and 50, Bloom. I go, yeah, but 15 and 10 is the fastest. Okay, now, when I do this, keep in mind, I've got 2x, okay, and x, and I got 15 and 10. 15 over on this side does 15 times 2 is 30, and 10, that's 20. That doesn't work. But if I got 15 here, and I got 10 over here, I got 20 and 15. Their difference is 5. And that's where I'm looking for, a difference of 5. So now, once I get that, one of them's got to be negative. The one that makes it bigger, so that one's there and that one's there, and I'm golden. And this is still equal to 0, by the way. Okay, so I factored them. And now, just like we did in Chapter 7, remember this is all stuff that we reviewed in Chapter 7. Once we review it, we're golden for it. I got 0 product rule. One of them is 0, okay, at a certain value for x. So I got to find those two values for x that make it 0. Okay, so now I solve those two relationships because of 0 product rule. I got x is negative 7.5. Okay, let's talk about the reasonableness of this answer in real world situations. Do I have, okay, other than the football field and in a submarine, do I have negative values? No. I mean, Death Valley, lowest point in the United States, you know, until we start tunneling. Well, here's the deal. I'm not going to use negative 7.5. It doesn't make sense in our situation, but I have to evaluate that every time because, you know, if I take negative 7.5, double it, I got negative 10. I subtract 5 from it, I got negative 15. Negative 15 and subtracting if I got negative 20. That doesn't seem to make sense for lengths of a diagonal. But I could go 10 and say, hey, 10 is one of my values. The other one is 15. Crazy, that was the number Bloom started with. I just started with that one because it was easy to use 10 and double 10 and be 20. But that's our answer for this. 10 and 15 are two diagonals that'll work together. If you don't believe me, multiply them. 10 times 15 is 150. Divide by 2, it's 75. Totally works. Now, back in Chapter 8, Section 2, we went over 30, 60, 90s, 45, 45, 90s. I alluded to the fact that they'd be here today. They're right here. They're sitting up right here, right in front of the class. Hi, wave. They're right here. You see them? They waved really fast. They're quick. Okay, they're kind of shy. Here's the deal. We've got 30, 60, 90. And I'm just going to remind you, 30, 60, 90, this is 30, that's 60, this is 90. If this is 2x, that's x, and this is x to the square root of 3. So I must ask, because that's 30, what's half of 8? 4, just like we're golfing, right? And then down here, this bad boy has got to be 4 to the square root of 3. Okay, now that's part of that base. That's part of that base, not half, part. The other part of that base is 15 minus 4 to the square root of 3, and that's the other base. And people are like, how do you know? Because remember, that's consistency in measure. When I drop that down, this is half, the other part I should say, that's 4 to the square root of 3 and 15 minus 4 to the square root of 3. So now, since that's up here, I'm going to move that. I got 15 as one base. 15 minus 4 to the square root of 3 is my other base. And I'm off to the races. Yes, sir. Yes, deer. I said deer. I got it on tape. I can run that back if you'd like to see it. I could, but here's the thing. When I give you a 30, 60, 90, or 45, 45, I expect you to use shortcuts, and these are the shortcuts, okay? And consequently, in my directions, I'll say, please leave your answer in simplest radical form. So it opens itself up to the shortcuts completely, okay? So know that, because I'll do the same thing on the quiz and the test, okay? But yeah, you can use sine, cosine, and tangent, but it's the simplest radical form stuff that we're looking for, because those are the things that are fastest for doing all the calculations, and you'll see that in ACT and SAT. Matter of fact, they write those tests so you do not need a calculator at all. You just use, there are shortcuts, 45, 45, 90, 30, 60, 90, okay? Now, I pop those in, I got 4, that's my height. Got that, 15 minus 4, the square root of 3. I got that written in from the other one, so I'll get rid of that. And we'll pop that out of there so we get all that crud out of there and out of our way. And I got 15 because that's my other base. And now I add the 15s, that's 30 minus 4, the square root of 3, times 2. What's 30 times 2? 60, right? 4 times 2 is 8. I got 60 minus 8, the square root of 3. If I wanted to, and if I was mean, heartless, and cruel, and I am, I would say, hey, write it in simplest radical form, and that's it. That's simplest radical form area. If I have a calculator and I ask you round to the nearest hundredth, you pop it in your calculator, round it to the nearest hundredth. Okay? Pay attention to those directions. They're going to be coming at you quite quickly during a test, and you got to know what they mean. Questions? We're doing all right? We have 3 questions left, and we're done with, well, 5 questions left. We're done with notes. 5 questions. 2 of them are 30, 60, 90. One of them's 45, 45, 90, and the other really are going to test whether you can count or not, and whether you can pay attention to units, whether something goes up by 1s, 2s, 3s, and so on. Okay, because the difficulty level is increased when it goes up by more than 1s. Okay, it almost makes you excited to get there, doesn't it? Okay, you ready? 30, 60, 90. Once again, we have to review our rhombus properties. Rhombuses, diagonals meet at a right angle. So I have 4 right triangles. Rhombuses are parallelograms, opposite sides are the same. But rhombuses are unique parallelograms because all the sides are the same. Okay, so all the exterior sides are the same in a rhombus. The diagonals bisect each other and they meet at right angles. The diagonals are mutual bisectors of opposite sides. So the opposite sides are split in half, and because the opposite sides are made up of parallelograms, or I should say angles, the angles are the same, and half that same angle is the same across. And what's that mean to us? This is 30, this is 30, because that's 60. And this is a 30, 60, 90 triangle. So I have 4 30, 60, 90 triangles here in this diagram. So I'm going to use 30, 60, 90 triangle skills. Half of 6, 3. Okay. This is 3 as well. And guess what? Because I've got the longer leg opposite the 60-degree angle, I've got 3 the square root of 3 and 3 the square root of 3. I add those 3 to square root of 3's together as if it was 3x and 3x. So it becomes 6 the square root of 3 times 3 plus 3, which is another 6. Okay, so I got that going on. Are there any questions on how I got those numbers? And that's the beauty of this, because if I was doing sine, cosine, tangent, I'd still be bogged down. Okay, now half of 6 is 3. What's 3 times 6? Exact answer, 18 to the square root of 3 feet squared, or simplest radical form. Okay, if I ask you to round to the nearest hundredth, pop in your calculator, 31.18. Okay, so that's where we're going. Now I'm going to give you a moment to look it over and consider the fact I have the same problem in the 15 and I gave you the short side. Go. Short side of the 30, 60, 90 triangle relationship. So it's very similar. So as the cable guy would say, get her done. Remember, every time you use a formula in your notes, you should have it written down. Every time you use a formula in your notes, it should be clearly set out what numbers go in. So that way when you review for a test or a quiz, you can quickly find them and go, oh, that's what I'm doing. The visual is so much better when it's written out. If you just have numbers, boy, I can't help you. People go, well, I didn't do very well on that test. Well, you're not doing very well on your prep for that test or quiz. You got to make sure it's reread of your notes, not a refigure. Rereading your notes is fast. Refiguring your notes is longer. So make sure you know that as we're going through. Now, keep in mind that 7's across from the 30-degree angle. So I know that this is 7 as well. And because of that, the side across from the 60-degree angle, that's 60, is 7 the square root of 3. So that's 7 the square root of 3. So I got 14 times 14 the square root of 3. Half of 14 is 7. 7 times 14, it's looking like 98. 98 the square root of 3 is 14 feet squared, is the exact answer or simplest radical form. And if I want you to round it, I'm going to round to the nearest hundredth because I like getting my pennies back, and when I buy stuff, I always wait. They'll take it from the borrow a penny thing and hand it to me. Oh, thanks. Okay, make sure you know. Now, here's the fun one. This one looks really hard because it's not a 30, 60, 90. It's a 45, 45, 90. Did you notice that a 45, 45, 90 is an isosceles right triangle? And since this is a right angle, this must be 4, this must be 4, and that must be 4. Hey, this is a square. It's not just a rhombus, it's a square. And people are like, how do you know? Because the diagonals are the same. 4 plus 4 are 8. Since the diagonals are the same, that qualifies as a rectangle. A rectangle with diagonals that are perpendicular, square. So now, I pop that in and get 8 times 8, 64, divided by 2 is 32, done, meters squared. And either way, whether I ask you to round to the nearest hundredth, or if I ask you to put it in simplest radical form, it's 32. If I ask you to round to the nearest hundredth, it's 32.00. Okay. Questions here? It's going quick. Today's Monday, Thursday, Friday schedule, and we're done at 1:08, and we got about 23 minutes left. We're going to do these next 2 problems, and then we have a homework quiz. No notes, except for the stuff I put on the board. Okay, so what we got next is counting with a purpose. Counting with a purpose. Check it out. I have 2 quadrilaterals. They have different sides, but they have diagonals that meet at right angles. Okay, the diagonals that meet at right angles are awesome little buggers because I'm just going to count, and it goes up by 1s. So it's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5. 6 times 5 is divided by 2 is. So that's what I'm doing. Maybe if it like recognizes that I'm alive, that's it. And I put on units because I don't want it going out in the public naked. Remember, dress up your numbers with units when you can, because they get embarrassed. Go, my person put me in this, or they forgot to put my units on. Okay, so go ahead and do the other one, and then after you're done, we are done with notes for today. While I take attendance and open up Schoology for you guys. It is ready for you to take, okay? Now, the last one that we've got, hopefully you're able to recognize 8 times 2 divided by 2 is 8. And we are done with notes, okay?